So many A-level maths students left this question completely blank. Let's make sure it doesn't happen to you this summer. In their report after the exams, the examiner said that a significant number of candidates found this question very challenging, with a fair proportion of blank answers, oh dear, and another significant number working with various substitutions in Part A that were quickly abandoned. Oh dear, it doesn't look like they started this question well. And in fact, in Part C, a significant number of candidates had no real idea how to even start this. Let's read through the question. It says, on a roller coaster ride, passengers travel in carriages around a track. On the ride, carriages complete multiple circuits of the track such that the maximum vertical height of a carriage above the ground is 60 metres. It says a carriage starts a circuit at a vertical height of 2 metres above the ground, and the ground is horizontal. It says the vertical height, h, of the carriage above the ground, t seconds after the carriage starts the first circuit, is modelled by this equation, where a and b are positive constants. It says in Part A, find a complete equation for the model. So we need to work out what's the value of a and what's the value of b, and then put them into this equation to finish. So what do we know about what this model looks like as a graph? Well, notice that it's really a quadratic, and it's a quadratic with a negative coefficient of the t squared term, of the quadratic term. Because b is positive, minus b would be negative. So what shape of the graph does this have? Well, it has this kind of shape. So we want to work out the value of a and the value of b. How can we do that? Well, to get started with this, we can use the fact that they gave us, that I'm highlighting here in orange, that the maximum vertical height of a carriage above the ground is 60. So that's going to relate to the turning point of this graph. Here, in this case, a maximum point. How can we work out the coordinates of this maximum point? Well, we can use this completed square form here to write down the coordinates straight away. We can write down that it's 20, a. How did I do that from this completed square form? Well, if I'm looking for the maximum value of h, which is really my y value here, remember t is like our x value. If I want the maximum value of h here, well, what I want to do is take away from a the smallest amount possible. So I want to make sure that I'm taking away something that's as small as possible. I know that the thing I'm going to be taking away is either going to be positive or, at its smallest, is going to be 0. How do I know that? Well, that's because what we've got here, this part that I'm highlighting in blue, that's a squared term. And I know that the result of squaring is always positive or 0. It can never be negative, right? If you square a number, you either do positive times positive, which gives you positive, or you do negative times negative, which again gives you something that's positive. Or you do 0 times 0, and that gives you something that's 0 as a result. So the smallest that a squared term can be is 0. So the smallest that I can take away from a is in fact when this squared part is 0. If that squared part is 0, then I'll have the maximum value of h would be a minus b times 0. Well, b times 0 is 0. So the maximum value of h, the maximum y value, will be a. Hence, I've written down that as the y coordinate here. When does that maximum occur? Well, it happens when what I'm inside here is 0. It happens when t minus 20 equals 0. In other words, when t equals 20. So that was how I was able to write down this coordinate here straight away. So you can just look at this, you change the sign of this from negative to positive, and you just leave this one as it is. You don't change the sign of that one. And that's how we can get the coordinates of the turning point. How is that helpful here? Well, it says in the question, highlighted in orange here, that the maximum vertical height of a carriage above the ground is 60. So that would be, if this is our ground here, that would be this height here, that would be 60. And that would be the y coordinate that we've got here. So therefore, a equals 60. So I know that this part is 60. If I substitute that into the equation here, I'll end up with this. What else? How can I work out this value of b? Well, it said here that the carriage starts a circuit at a vertical height of 2 meters above the ground. So that's really talking about this distance here. It's talking about this point here, the y-intercept, or the h-intercept here. So when t equals 0, h will equal 2. So we can substitute t equals 0 into here at the same time as h equals 2 into here, to end up with h2 equals 60 minus, well, it would be minus 20 squared, because this part is 0, which is 400. So 2 equals 60 minus 400b. If you rearrange the equation, you get this. Divide by minus 400, and we get our b value as a decimal. Take the b value we've just worked out and substitute back into here, and we'll end up with the equation for the model, the complete equation here. Part B. Use the model to determine the height of a carriage above the ground when t equals 40. So we take the equation that we had from part A, that's what we have here, and we can simply substitute in t equals 40 into the equation. So replacing t with 40 in here, and then putting all of this into your calculator all in one go, gives you the answer h equals 2. Don't forget to give the units. We're talking about a height above the ground. Remember, the height was measured in meters, so we should include the units too. Part C. It says, in an alternative model, the vertical height h meters of a carriage above the ground, t seconds after the carriage starts the first circuit, is given by this equation, where alpha is between 0 and 360 degrees, and alpha, which appears here, and beta, which appears here, are both constants. It says, find a complete equation for the alternative model. So here we need to work out what is alpha, what is beta as a number, and then substitute each of those back into this equation to give the complete equation for this alternative model. So let's start with the equation they gave us, h equals this. Let's think again about the maximum value of h, just like we did in part A. What would the maximum value of my height be? Well, I've got no control over 29 or beta, but I do have control over this, right? Because this changes in size as t changes. As we change the value of t, the size of cosine of this will change. But you should know that the cosine graph wiggles up and down between -1 and 1. -1 is the minimum value, and +1 is the maximum value. And we want the maximum value, because we know that the maximum height of the carriage above the ground is 60. So we know that the maximum height will be when this part here is equal to 1. So replacing that part with 1, and using the fact that we know that the maximum is 60, we end up with this equation, which we can then solve for beta. We can work out that beta is 31. So if I replace beta with 31 in the original equation here, then we have this. I still need to work out the value of alpha though. How can I do that? Well, I can use that other piece of information that we had in the question. It said a carriage starts a circuit at a vertical height of 2 meters above the ground. So when we're starting, time will be 0. So it's really saying when t equals 0, h equals 2. So we can replace both of those things into our equation for h that we've just come up with. So t equals 0, that can go in here, and h equals 2, that can go here. So like so. And if we do the number crunching on this, in the bracket here, we just end up with alpha. And if you subtract 31 from both sides, you'll end up with -29 here. Next, if we divide both sides by 29, we have that cos alpha is -1. When does that happen? Well, if you apply arc cos to both sides, you'll solve for alpha in the interval they gave you between 0 and 360. The only value of alpha is 180 degrees. Remember, this question's a question in degrees, not radians, so make sure you follow suit. So now we know that alpha is 180 degrees. We can then replace that back into the equation here, and we have the complete equation of the model at the end here. Part D. It says, given that the carriage moves continuously for 2 minutes, give a reason why the alternative model would be more appropriate. It's only 1 mark. The mark scheme allows several different options for this, so you can score a mark for a reason which makes reference to any of the following. I would only give one of them though, because there's only 1 mark. You don't want to confuse the examiner with one thing that you say is correct and the other thing that might not be correct, so just pick one thing to say. Any of these though would score the mark. It says, the alternative model allows repetition, so this is a cyclic equation, it's periodic, right? This cosine, it kind of wiggles up and down, repeats itself. Whereas the original model, this quadratic, can only go up and down once. It's just a quadratic, right? Alternative, you could say that in the alternative model, after 2 minutes, the carriage will be back at the start. So again, kind of referring to this cyclic motion of the alternative model. Or you could sub in a sufficiently large value into the original model and show that actually that h would be negative for a sufficiently large value of t, for example, t equals 40, or any time after this. That can't happen, right? Height can't be negative. Or you could say that in the original model, well, after 2 minutes, which is what they were saying here, the carriage wouldn't be back at the start. So we need to say something specific. They specifically say in the mark scheme that vague responses on their own, like the original model is a parabola, doesn't score the mark. You need to be more specific than that.